All right. Hey, everyone. So these are the walkthrough of some kind of some like practice problems from the 10-4 information. So the first one is a sample exercise 10-4 of page 403. Calcium carbonate, CaCO3 solid, decomposes upon heating to give calcium oxide solid and carbon dioxide gas. A sample of calcium carbonate is decomposed, and the carbon dioxide is collected in a 250 milliliter flask. After the decomposition is complete, the gas has a pressure of 1.3 atmospheres at a temperature of 31 degrees Celsius. How many moles of CO2 gas were generated? So the first thing I'm going to do is I'm just going to kind of like identify variables here. So the 250 milliliter, like the dash the milliliter, this is the size of the flask. That's not the amount of anything that's in it. Okay, so that's not an amount of a measurement. The gas had a pressure of 1.3 atmospheres, right? At a temperature of, okay, so we got temperature is 31 degrees Celsius. And remember, for these, the gas equations, you always have to turn Celsius to Kelvin. So we're going to add 273. And this gives us, what is that? 304, I think. Yeah. All right. How many moles of CO2 gas were generated? So we're looking for N. Okay. It's okay. Sorry. So the volume, because it's a gas, it fills the container it's in, right? Or correct? So the 250 milliliters actually is the amount, the volume, because it fills the entire flask. So while this is the size of the flask, because the gas expands to fill the container, the volume would count as 250 milliliters. All right. So if we look at what we have the information here for doing Pivnert, right? The PV equals nRT, right? Now, if we look at our labels and we look at that conversion sheet, so let me grab it real quick here. So if we look at the conversion sheet, what we have to do, the way that we choose the constant, the R constant we use, is we look at the labels that we have and try to choose the one that either doesn't need converting or needs the least amount of converting. So we've got pressure in atmospheres, temperature in Kelvin, and volume in milliliters. So if we look, do we have one that has atmospheres, atmospheres in Kelvin, and well, they all should have Kelvin. So atmospheres in milliliters, like, no, we don't have one with atmospheres in milliliters, but we do have atmospheres liters. So we can convert our volume from milliliters to liters by just moving decimal 3 to the left. So 0.250 liters. Okay. Now, if we plug in our pressure, our volume, we're looking for the N, the number of moles. We're going to use the R with liters, atmospheres, moles, K. So this number, 0.08206, and that's the label is liters, atmospheres over moles, K, like that. Okay, and then our temperature is 304 K. Okay. Then now at this point, it's just a math, an algebra problem solving, getting it alone in solving for the missing variable. So we just take this times this divided by that. And this kicks us out 0.013. And our label, now atmospheres cancels, liters cancel, Ks cancel, we're left with moles. So 0.013 moles is moles of CO2 is our answer. All right. Okay, so that was that one.